Now we're going to be reviewing some questions from homework number 2. There were a couple mistakes a lot of people made. I'm going to go over a problem that the solution isn't in the back of the book, and then I'm going to go over this extra question I gave. Right, so the first question we had here was asking you to draw a tree diagram for all the ways to guess on a quiz that has 2 true-false questions and 1 multiple choice question with 4 answer choices. So first we need to, make note of what we have. So this quiz has 3 questions on it. The first question is true, false. The second question is true, false. And then the third question, it's multiple choice with 4 answer choices. So we'll call those answer choices A, B, C, and D. You can call them whatever you want. It doesn't really matter. All that matters is we know we have 2 choices for our first question, 2 choices for our second, and then 3 choices for our third. So we'll start with what happens for the first question. We have 2 choices. We can guess true or we can guess false. That's it. Now for our second question, there are 2 choices again. You can guess true or you can guess false on each of these questions. Now, there were plenty of you that did this much correctly and there wasn't a problem with. I don't know if the wording of the original question wasn't that clear to indicate that all 3 questions were on the same quiz, but there were some of you that messed up on this part and didn't include, you did a separate tree diagram for the third question. What we need to do now is, if our third question has 4 choices, well, after we've made our first 2 choices for questions 1 and question 2, now for question 3, there's 4 possible choices that we can make for each one. Right, so this would be our tree, and if we wanted to count up how many possible, so put this here, if we wanted to count out how many possible ways that we could guess on this test, we could count the ends of our branches. So there's 16 possible ways to guess on this quiz. All you had to do in this question was draw out the tree diagram. You didn't have to generate the sample space. Some of you did, which is good. Had you been asked additional things about this, but we didn't have to do that. So now let's look at question 5.12 on page 272. So in this problem, we're told that there's 7 VCRs that can be rented and 3 of them are defective. Then we're being told that 2 VCRs will be rented together. The fact that they're being rented together is important. What this tells us is that this is a problem where we're taking things out of a group of objects without replacement, or that they're dependent events. The reason for that is because if we were dealing with independent events, that would mean we're renting 1 VCR, we're returning it, and then we're renting another one at random. And if that were the case, we would be able to rent the same VCR twice in a row. But if we're renting 2 VCRs together at the same time, they have to be 2 different VCRs. You can think of it as renting 1 at random and then going back and picking another one at random to rent again. So you can't rent 2 of them, like you're renting 2 different VCRs. You can't rent the same VCR twice. If these were independent events, you would be able to rent the same VCR twice. Now we'll look at what questions they're asking us. First, they're asking us to find the probability both are defective, then the probability that neither are defective, then the probability that only one will be defective. The probability that both are defective is the same thing as the probability of the first one being defective and the second one being defective. So the probability that the first one is defective, well, we're told, okay, we have 3 that are defective out of 7. So that's going to be 3 out of 7. Right, now we're multiplying this by the probability that the second one is defective. Because these are dependent events and we're renting without replacement, the probability that the second one is defective, well, now there's only 6 VCRs left, and we've rented one of the defective ones already, so it's only 2 of them left now that are defective. We multiply these together and we get 6 out of 42, which we can simplify to 1/7. For the next one, the probability that neither is defective is pretty much the same as the first one, except now we want to find the probability that the first is not defective and then that the second one is not defective. So the probability that the first one is not defective is going to be 4 out of 7. We were told 3 of them had defects, so that means out of 7, so 4 of them are not going to be defective. Then we'd multiply that by the probability that the second one is also not defective. Since we've rented one already that is not defective, now there's only 3 left that don't have defects. And because we rented one, we only have 6 now instead of 7. And we multiply these together, we get 12 out of 42, which reduces to 2 over 7. Most people were okay with this. The only big mistake I saw a lot of people make here was confusing whether this problem was dealing with replacement or without replacement, or whether they were independent events or dependent events. Now, a lot of people, even some of you who understood that these were dependent events, had some problems here. So what we have to do here is we have to consider a couple of different cases. We're looking for the probability that only one of them will be defective. If we think of this as renting one and then renting another, it's a little bit easier to see. So the 2 ways that we could get only one movie that's defective is the first one could be defective and the second isn't, or the first one is not defective and the second one is. Okay, so the 2 ways this could happen: first one could be defective and the second one isn't, or the first one is not defective and the second one is defective. The probability that the first one is defective is going to be 3 out of 7, times the probability that the second is not defective, given that the first one was, is going to now be 4 out of 6. And now, because this is OR, we're going to be adding this probability to the probability of this situation. The other thing that could happen is the first one's not defective, so the probability of that would be 4 out of 7, times the probability that the second one is defective, given the first one is not defective, is now going to be 3 out of 6. So we multiply these guys together and then add them together, and we end up getting 12 out of 42 plus 12 out of 42, which adds up to 24 out of 42, which reduces to 4 over 7. And another interesting thing that we might notice here is if we consider all possible outcomes of this experiment, these are all possible outcomes of this experiment. You could get 2 defective BCRs, you could get 2 that are not defective, or you could end up with the first one defective, the second one isn't, or you could end up with the first one is not defective and the second one is. If we add 6 over 42, 12 over 42, and 24 over 42, those add up to 42 over 42, which end up being 1. So the probabilities of all possible outcomes of any experiment, if we add them together, it's guaranteed to add up to 1. So that is one way that you can check your work for some problems like this, if you know every possible outcome of the experiment you're dealing with. Now, one other thing that I wanted to talk about is this is not a particular homework problem, but there were quite a few people who had you had the right logic for how to solve problems, but you had incorrect answers because, you incorrectly multiplied fractions or you incorrectly added fractions. So, just to remind you how that works, if we have a fraction a over b times c over d, you multiply numerator by numerator, and then you multiply denominator by denominator. So for an example, let's say we wanted to do, 1/2 times 1/2, times 1/2, right? We would do, this is going to be equal to 1 times 1 times 1 over 2 times 2 times 2. And this would end up being 1 over 2 times 2 is 4, and then times 2 again is 8. Right? Or even if we just did, a half, times 3 over 5, this is going to end up being 1 times 3 over 2 times 5. ends up giving us 3 over 10. And then for adding fractions, you can only add fractions when they have like denominators. You don't add the denominators, you only add the numerators, and the denominators have to be the same. So an example for this, let's say we have a half plus, 3 halves. This would end up being, 4 over 2, which, is going to simplify to an actual number, but we're just going over how we would do this. If you don't have another thing is you can use your calculator to multiply and add fractions. You do have that as an option. And again, since if you don't have one of these, you can go online. There are free, they're free TI-83 emulators that you can download on your phone. I know there's definitely a free one for Android. I believe there may be some free ones for iPhone too. There are also, free ways that you can emulate this calculator or the TI-84 on your computer if you have a computer. So those are other options you have, but if you're not working with a calculator like that, it's really silly to end up losing points on something or potentially, get a question on an exam wrong because, you know what to do over here, you know what to do here, but, you multiplied these incorrectly. So, yes. Now we're going to review reducing fractions a little bit. This is more just in case, some of you are a little bit unfamiliar with this to help you, be able to do better on the quiz that we're going to be having on Thursday. So let's say that, you have a problem on the quiz and you solve it and the answer that you get is 26 out of 52, but you don't see that as an answer choice in the choices that you have to choose from because you're going to be having a multiple choice quiz. You might need to reduce 26 out of 52 to another equivalent fraction. This reduces to a half, but we could also potentially see this written as 13 over 26. Those are other ways that we could end up expressing the same fraction. So now let's say that you see a couple of different answer choices and 26 out of 52 is the answer you got, but you don't see, 26 out of 52. Other things that you can do to, determine if a fraction is the same is if you evaluate 26 out of 52 on your calculator, you should end up getting 0.5. Then if you hit the math button and the fraction button, you'll end up getting 1/2, which is the reduced form of 26 out of 52. Now let's say you see something like 13 out of 26 as an answer choice and you want to check, could this be the answer? But you don't see 1/2, you don't see 26 out of 52. You can also put that in there. And you can see, okay, well, this is also equal to a half. So that'll tell you both of these fractions have to be the same if they both come out to the same decimal. So if you get an answer and you want to check it against the other answer choices you have there, because you don't see them there, what I'd recommend doing, to make sure that they're all the same is you're allowed to use a calculator for this, obviously. You can put them in your calculator, see if you get the same decimal for them.